This question says, the preparations of two aqueous solutions are described in the table below. For each solution, write the chemical formulas of the major species present at equilibrium. You can leave out water itself, so that's important. So the first one, we have 1 mole of NaOH is added to 1 liter of a 1 molar HCN solution. So if we have 1 liter of a 1 mole per liter solution, we also have 1 mole of HCN. So let's look at this reaction. So we have HCN, aqueous, a weak base, or excuse me, a weak acid, plus NaOH, aqueous, a strong base. So we have a weak acid and a strong base, and they're going to react to form, H goes with OH to form water, liquid, plus NaCN, aqueous. And we have 1 mole of this and 1 mole of this. So since we have 1 mole of each, and if we take a weak acid plus a strong base, it'll react completely, we're going to end up with none of these two things being still in the reaction mixture. Notice the stoichiometry is all 1 to 1, and we have the exact same number of moles of each. So everything we're going to have is water and NaCN. Now it specifically says you should leave out water, so we have to focus on the NaCN. So, like a question on the previous playlist, what does NaCN break up into? We have Na plus aqueous and Cn minus aqueous. Na plus is a 1A metal. It's neutral, so it goes under other. Cn minus is the conjugate base of the weak acid HCN. So this molecule is a base, Cn minus. Let's look at the other example, which is a little bit more complicated. We have 0.16 moles of KOH is added to 1 liter of a solution that is 1 molar in both HCN and KCN. So it's 1 liter of 1 molar HCN and KCN, which means we have a mole of each of these compounds. So let's look and see what happens. This is very similar to the previous reaction. It's only KOH, except the amounts are different. So we have HCN, aqueous, plus KOH, aqueous, yields water, liquid, and KCN, aqueous. So potassium is the ion. But the major difference here is the amounts. And in fact, it's probably better to write this as a reversible arrow. So let's take a look at what's going on here. Well, we start with 1 mole, so this is initial, if you will. We're not going to do an ice table exactly, but we're going to have initial and equilibrium. We start with 1 mole of this, 0.16 moles of this, and we have 1 mole of KCN. At equilibrium, what's going to happen? Well, 1 mole of this and 0.16 moles of this are going to react, which is going to give us 0.84 moles of HCN at the end, no moles of KOH because it's the limiting reactant, and 1 plus the 0.16 more, or 1.16 moles of KCN. So now let's look at what's in solution. Well, in this case, there's clearly HCN in solution. There's 0.84 moles of it. So the acid is HCN. Bases. Well, we have Cl minus still in solution. So that's going to be the base. And we have K plus, which counts as an other because it's neutral. So that's how you could do this problem. Note that you need to both find the reaction and consider the amounts of things, because these are essentially the same reaction. But in one case, the amounts drove the reaction to completion, and in the other case, it did not, which definitely changed the answers that we have.